Hey everyone, so we're going to be solving question 15 called threesome, and the question asks us, given an array integer nums, return all triplets, nums of I, nums of j, nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums of I plus nums of j plus nums of k is equal to 0. So what this means is we can't reuse the same indices multiple times to get it to add up to 0. And we also make sure that every single indices that we use is unique. And then it says, notice that the solution set must not contain duplicate triplets. We'll figure out what that means in a bit. So in the first example, if this is our nums array, we look for triplets that add up to 0. In this case, this adds up to 0, and then -1, -1, 2 adds up to 0. Let's say, for instance, we had another -1, right? Then for each -1 that exists currently, then it could be paired with that new -1, so that's 2 additional -1s that could be added, but since it doesn't allow duplicate triplets, we'll only list it once. And then for the second example, we have a triplet of 0, 1, 1, and since triplets don't add up to 0, we have nothing in our output array. And then if our input was 3 zeros, then since 3 zeros add up to 0, and all the indices are unique, we can just output the 3 zeros as a result. And this is not a super obvious implementation. It kind of requires knowledge of a question similar to twosum called twosum with integer array sorted. And the premise of that question is, can we find out if a sum that we want exists if you add up 2 values in an input array? And the idea is, since the input array is sorted, if the value that you have currently, so the current sum of the left and right pointer is too small, you move the left pointer in, and if it's too large, you move the right pointer down 1, right? So how can we use that logic in this question? Well, if we fix a value in the array, then 0 minus that value should exist in the remaining n-1 values. And if it doesn't exist, then we know that a triplet cannot be made with those exact indices. And we're always going to use left and right starting immediately after the value you fix, because otherwise we'll be doing computations that we've already done before. So let's start implementation and I'll explain it better. So we'll do nums.sort. This allows us to use the 2-pointer approach, and then res is equal to an input array. And then remember, we're going to fix a point, and this will be our starting point when it comes to the sum. So for I n in enumerate nums, what we're going to do is, since we're going to check left pointer being the value immediately after and right pointer being the end, we can check the case where if n is greater than 0, then we could break. And the reason we could break is, since it's sorted, if n is already greater than 0, taking the sum of 3 values greater than 0, you'll never get 0, right? And then since we're not allowed to do duplicates, we can always skip duplicates that exist. So as long as I is greater than 0 and n, so this is the value of this certain nums of I, is equal to nums I minus 1, we can continue so that we don't recompute this triplet again, right? Because the fixed value can cause duplicate values if it's the same fixed values. Alright, so remember, we start at the value immediately after. And once again, the reason we do this is because if we start at 0 every time and the last index every time, notice how every value in between will be computed multiple times. And if you don't understand why, I suggest you kind of trace it out and then get back to me, right? So R is always going to be len nums minus 1. And the reason this is the case is because it's always going to be the last value that we haven't computed after the current value. So now this is where the traditional two sum with sorted array comes in. So while L is less than R, our sum is equal to nums of L plus nums of R plus n. And then if num is greater than 0, what happens is we have to subtract 1 from our R. And then if num is less than 0, which means we need higher values, we can add 1 to L. Otherwise, the last case is nums is equal to 0. So we can just append all the triplets. Or is that append? Nums of L, nums of J, as well as n. And then we want to make sure that our while loop doesn't permanently get stuck. So we add 1 to L, and then subtract 1 from R. And then we can return res. Let's run this, see what happens. Yeah, so nums of L, nums of R, n. Oh, we can make this into a list. There we go. -1, -1, 2. -1, 0, 1, 1, 1, 0. So the problem is that one of our conditions is wrong. Let's figure out which one. This part looks completely fine to me. This part looks good to me. Left is the first value after I, makes sense. R is the last value. And then while left is less than R, num is equal to nums of L plus nums of R plus n, which makes sense. If sum is greater than 0, we subtract it from R. Num is less than 0, we need to add another value to the left index to get a larger value. Makes sense. Otherwise, we append the results. The one thing I can think about that can possibly help us is checking this condition, right? Because most of the time we have duplicates inside this while loop, and if we don't catch it, then it won't continue. So what we can do to prevent duplicates is to add another while loop. So while nums of L is equal to nums of L minus 1, and we also have to make sure that L remains less than R. We're going to do L plus equal to 1. See what this does. Okay, yeah. So let me take a look. It seems to me like this adds up to 0, this adds to 0, but this one doesn't add to 0. So what exactly is wrong with the code? Let me rename this to sum, let me rename this to sum, let me rename this to sum. Nums of L, nums of R, n. Makes sense, makes sense, makes sense. I just need to figure out why this one is also being placed into the loop. Let's run again. Print sum sum. Sum is 3. Sum is 3, and it doesn't even look like 3, to be quite honest. Sum is equal to nums of L plus nums of R plus N. If it's too large, subtract 1 from sum. L if, oh, I see the problem. Since we have an if statement here, this else will always be connected to this if statement, which isn't always the case. It should be if these two are false. So let's do that, and then we solve the problem. Yeah, I think that makes a lot of sense to me. Just make sure you have your else ifs, otherwise your else's will be connected to your if statement here, and it would make your solution wrong. But yeah, hope this taught you something.